Hi, I'm Adam Chalmers, a software engineer at Zoo.dev. We're making a new CAD suite. We're making a CAD product called Zoo Design Studio, and it's powered by a programming language we made called KCL, the Kitty Cat language. Most software programming languages are most programming languages are for software. They are designed to output piece of software. This one's a little bit different. It outputs CAD models. So in the previous couple of videos, I showed you how to get started with KCL, kind of basics of the language, and then I showed you how to use KCL to do interesting 2D sketches. 2D sketches are a pretty common part of mechanical engineering. And in this video, we're going to take those 2D sketches and we're going to look at how to make 3D models from them. So let's get started. I'm in Zoo Design Studio right now, so I'm going to open up the code panel. You can do Shift-C to open up the code panel. And let's get started. Let's do a sketch on the XZ plane. So start sketch on XZ. Now in the previous video, we looked at how sketching works. So I'm not going to go into too much detail here, but we're just going to use a couple of quick, easy helper functions. So let's just use the polygon helper function. Polygon gives you a regular polygon. We're going to make a polygon with sides of length 10, 4 sides, so it should give us just a nice normal square. Let's make this a little bit bigger so we don't have to worry about zooming in or anything. Yeah, let's make a nice square. We can right click and we can center, and we can just start zooming in a little bit. Yeah, there's our nice little square. Now, I mentioned we're going to be taking these 2D shapes, I'm going to be dragging them to make 3-dimensional shapes. The first way you can make a 3-dimensional shape is called extruding. Extruding is the most basic way to make a 3D shape from a 2D shape, but it's very, very useful and it's worth looking into. So let's use the extrude call. We're going to do a new pipeline. Remember, as we covered in previous videos, in KCL, this little pipeline operator here says take everything to the left, so this whole piece of code, and pipe it into the code coming to the right, which will be the extrude call. The first argument of extrude is a sketch to extrude, and the next argument can be the length, how far up to extrude it. Remember that the percentage sign means everything to the left of the pipeline. So this percent says take everything here and put it into this argument, the special first unlabeled argument. And then we'll give it the length to extrude. Let's make the extrude a little bigger. Let's make it an extrude with length 50. So you can see we've taken our square and we've pulled it up into the y-axis to make a 3-dimensional kind of square, make a 3-dimensional cuboid thing. We can make an actual cube if the length is equal to the square's length. It looks a little different with the perspective. Yeah, there you go. You've made a 3D shape. We took our 2D sketch and we extruded it up into the 3rd dimension to make a 3D shape. So let's take a look at some more advanced ways to model a 3D shape. The next one I want to show you is called a sweep. Let's kill this extrude. Let's go back to our 2D square. And we're going to do a sweep. An extrude, as I said, drags a shape into the 3rd dimension. The sweep also drags a shape into the 3rd dimension, but it can drag it along any kind of interesting path you can choose. So let's draw a more interesting path in that straight line. Let's do another one. Let's have start sketch on, and we'll do it on XY, because it's got to be on a different kind of plane, so we have something to actually pull it up into. So I'm going to use the XY plane now, and let's start a profile. We're going to start sketching at 0, 0. And then we will draw, let's do a straight line of length 200. And then we'll do a tangential arc, an arc that starts at the end of the previous line and kind of moves smoothly along in a tangent. Let's make it go 100 along the x and 50 along the y. So yeah, this kind of shape. Now we're going to give both these shapes variables. We're going to assign them to variables. We can reference them later. So let's call this my square, and let's call this path to sweep along. So now we can use the sweep call. So the first unlabeled parameter is the shape to sweep, and then we'll give it the path, which should path to sweep along. And see, it's pulled that square up and into. So this looks a little bit interesting. We have it's kind of intersecting itself a little bit. So let's give it a little bit more room to operate. That's not exactly what we wanted. Let's make this length 300, maybe 400. And then we'll make this arc move a little further as well. I guess it could just keep it at 100. 200, but let's make this arc a little bit further out. Let's say this goes 400 out and 200 out. Yeah, that's a little more interesting. Let's make this a little longer. Let's make this go 400. Okay, so that's a more interesting shape. Let me comment out the sweep code so you can see what it's doing. It's basically taking this shape, this square here, and it's moving it along this path here. So if I rotate it around, so yeah, you can kind of see that I'm taking the square and I'm shifting it up into the third dimension along this path. So here's the sweep. Okay, so I'd like to do something a little bit more interesting than the plain old extrude we saw before. This is going to be pretty useful for making some interesting shaped parts. The next method we can use is called a revolve. So let's get started with that. So revolve is going to take this square and it's going to revolve it around the third axis, the y-axis in this case. So let's offset this a little bit so we have something to revolve around. So I'm going to offset it by 200, and then we're going to do a revolve where the axis is y. But here we go, we have our revolve. So we've taken our square and we revolved it around, you can kind of imagine a line in the middle for the y-axis, and you can see we're revolving it around that middle line. You don't have to do a full 360 revolve. You can set it to whatever angle you want. Let's do only half of a revolution, 180 degrees. And you can see clearly what's happening here. We've taken the square and we're revolving it around this y-axis halfway. We can do any kind of angle here, so we can do a very short one. We can just do it, a 45-degree revolution. So only revolving it around a really tiny fraction of the axis now. And we can just keep expanding that. Let's make it, 135 instead, and it'll go even further around. We can do 240. And finally, let's build it back up to the full 360-degree revolution. Cool, so you can make a whole heap of really useful parts with the revolve call. The last one I want to look at is called lofting. All the previous calls we looked at, where you had a sweep, or an extrude, or a revolve, they all took a single flat 2D sketch and they made it into 3D. Lofting is a little bit different. With lofting, we take multiple 2D shapes and we kind of join them together. We make a new interesting 3D shape that kind of smoothly goes from one 2D shape into the next one. So let's take a look. We are going to make some new shapes. Let's add a new circle. So here we're going to make a new circle that is going to be 50 units above the XZ plane. And let's bring this back to the center so it's a little bit easier to see what's going on. Yeah, so we've got our square and we've got a circle, and the circle is 50 units off the XZ plane. Right, you can see here we've got this plane here. Let's call this 50 above. 50 above. I'm using the offset plane call to do that. In fact, you know what? Let's just call this above. And let's make it a little bit taller. Let's make it 100 units above. And now we're going to loft the square into the circle. So we're going to do a loft call. We're going to give it an array of different shapes. And we're going to loft my square into circle top. And there you go. We've made a new 3D solid, which kind of starts at the square, moves up into the circle, and kind of smoothly interpolates from one into the other. So you can see it's trying to figure out a way to kind of join the square into the circle. We can add more shapes to this. So let's add another circle. Let's say start sketch. Oh, and then let's do an offset plane again. We'll take XZ, but we'll offset it to, 100, 200 this time. And then we'll make a circle with it. Say radius, let's make it smaller this time. So we've got our initial loft, and we've got this new smaller circle that we've got here. Again, in KCL, we have this kind of nice feature where if you click on something in the scene, it'll highlight the code that created it. And if we click on something in the code, it'll highlight the object in the scene that it corresponds to. So that's an easy way to check what your code is actually doing and to find which things your code matches up to. So it's quite useful. Anyway, let's add this new smaller shape into the loft. We'll give it a name, you know, small circle, and we'll add it to the loft. Okay, you can see we've made a, you know, it's taken the existing shape and it's added the small circle. Let's see before and after. And after. There we go. Okay, and we can even add another square into it. Let's just define the square inline here. No, let's make top square, and we'll have this top square start sketch on offset plane of xz, where the offset is 300. Take everything there, we'll pipe it into the polygon function. So let's make it a pentagon. Say num size is 5, radius is, let's say 40 again, and the center is 0, 0 again. So yeah, you can see this lets you make a whole heap of really interesting shapes. We can experiment pretty easily. Let's say make this bigger. Let's make it a radius of 80 instead. And we get, yeah, maybe a kind of, this kind of looks like a candlestick holder to me. Yeah. So yeah, that's how lofting works. Now there are some other functions you can, other arguments you can give to the loft function. Like you can choose the degree of interpolation. By default, it's 2. Let's see what happens if we increase it to 3. We kind of get a somewhat smoother shape. We can bump it up to 4. Oh, nope, 4 is not possible. There are too few sections. You want to keep the V degree. The V degree is kind of limited by how many shapes you're lofting between. So let's take a little example. Let's take a look at the difference between V degree 3. Let's see, kind of nice smooth sections. And if we do V degree 1 instead, you see we get this much more angular representation instead. So you can experiment by setting different V degree to get smoother or harsher kind of joins between the different shapes. Like I said, it defaults to 2. So if we put 2 here, if we put 2 there, or if we remove this parameter entirely, it's going to be the same shape. So yeah, there you have it. We started with simple 2D shapes like circles and squares. And you can see we have a whole heap of different methods you can use to make 3D solids from them. You can extrude them up into the 3rd dimension with the extrude call, or you can sweep them up into the 3rd dimension, passing in whatever kind of interesting curve you want to sweep them along. You could sweep them in a spiral, or an arc, or whatever you want to do. You can revolve them, where you take the shape and you kind of move it around the middle axis, or you can loft several shapes into each other. So these are 4 different methods you can use to take 2D shapes and create 3D solids from them. Hope you've enjoyed this little KCL tutorial. In the next one, we're going to be taking a look at what you can do with these 3D solids once you've got them, how you can combine them and alter them to make new, interesting designs. See you next time.